we've seen that both convenience samples and voluntary response samples produce bias. So we need a better way to choose a sample. And we're going to do that by taking a random sample. So a sample chosen by chance eliminates the problems of favoritism by the interviewer and self-selection by the respondents, which are the problems we had with the convenience sample and voluntary response sample. A simple random sample, or SRS, of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample selected. So, for example, if I have a class with 10 students and 2 problems that I want done by a student on the board in front of the class, I need a way of choosing where any pair of students will be equally likely to be the ones that are selected to come up and do the problems in front of the class. So in that case, drawing names from a hat is an example of a simple random sample that would work for that class. But this will be inconvenient for large populations and sample sizes, so I want a better way. And the way that we're going to choose our random samples is using a table of random digits. So this is one way, but in practice for really big samples, computers are actually used to choose a random sample. So what is a table of random digits? Well, it's a list of the digits from 0 through 9 with these 2 properties. First, each entry in the table is equally likely to be any of the 10 digits from 0 through 9. And second, the entries are independent of one another, so knowledge of one part of the table gives no information about any other part. So a bad example of a table of digits that wouldn't qualify would be if I had a table that had 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and 9, 9. This is not a good example because if I look at the first 6 digits here and I've got 2 zeros and then 2 ones and then 2 twos, I could guess that next I would see 2 threes. So that's not good because that breaks number 2 here. So let's look at a table of random digits. So here I've got a big table with a bunch of numbers in it. And you can see that there is no pattern, so we can't predict what a number in the table will be from the numbers that are around it. The digits in the table are displayed in groups of 5 to make the table easier to read. And I've also labeled the rows here from 101 through 125. But the groups and the row numbers are just for our convenience. So the table is actually just one long string of randomly chosen digits. And we want to use this to somehow get a random sample of a population. So let's look at the steps that we're going to go through to do that. So to use a table of random digits, my first step is to label my population. So I've got some population that I want to choose from randomly. And I'm going to give each member of the population a numerical label of the same length. So if I've got up to 100 items, they can be labeled with 2 digits, so I can label them 0, 1, 0, this should be 0, 2, 0, 3, all the way up to 99, and then 0, 0. So that gives me 100 labels that are all 2 digits long. If I had more than 100 items, anywhere up to 1,000, then I'd need to use 3-digit labels. My next step is to pick a row from the table. So without looking at the table, you can just use your finger to randomly point and select a row. And there's a table of random digits in your book that you can use for this. And your sample set is going to contain the individuals whose labels you find in the table starting from that row. So once you've picked your row, you can read the table and find successive groups of digits of the length you used as labels. So we've pick a row and we're going to break it up into labels of the length that we've chosen for our population. And once we do that, we need to ignore the ineligible labels. So from the labels you've generated by just reading across that row in step 2, you're going to ignore the ones that are outside the size of your population. So if my population is only, say, of size 20, and I've labeled my population 0, 1, 0, 2, and up to 20, and I see anything bigger than 20 in my list of labels that I got in step 2, then I'm just going to cross those out. So I cross those out, and also if I see any duplicate labels, so if I see 05 appears twice in my list, then I'll cross out the second time it appears. And I only go until I reach the sample size I need. So if I had a population of 20 and I wanted to randomly select 5 from that, I would just keep going until I get up to 5 labels that I could use, and after that I just ignore everything else. So let's go through an example of actually doing this. So I have all of the songs from the CD Disco Classics on my MP3 player, and I want to choose 5 random songs to listen to on my morning run. And the songs are listed below, and I will use the table of random digits to choose my playlist. So I've got 20 songs, and I've just labeled them with the track numbers here. So that's my first step, is to label my population. So the population in this case is all of the songs on the CD, and then each song is labeled with its track number. Notice that I've put a 0 in front of the first 9 track numbers to make them all 2-digit labels. So I've got 0, 1 up through 20 as my labels. The next step is to pick a row from the table. So I have randomly picked row number 116 in the table and copied it here. Now I want to read across and take 2 digits at a time as I read across the row. So if I do that, my first label is going to be 14. My second label is going to be 45. My next label is going to be 92. If I keep going, this is what I get. So I get 14, 45, 92, 60, 56, 31, 42, 48, and so on. So this is just the same numbers that I had in my row, but I've split it up so that they're in 2 digits instead of in groups of 5. Alright, so that takes care of step 2. Now step 3 is to ignore the ineligible labels. So I want to cross out the labels that aren't between 0, 1, and 20. So those would be labels that don't correspond to any songs on my CD. I'm also going to cross out labels that are duplicated and any labels that are left over after I have the 5 I need for my playlists. So let's just go across. First I'm going to cross out labels that aren't between 0, 1, and 20. So 14 is a good label, 45 is not, 92 is not, 60 is not, 56 is too big, 31 is too big, 42 is too big, 48 doesn't work either, 03 is a good label because that's between 0, 1, and 20. 71 doesn't work, 65 doesn't work, but 10 does because it's between 0, 1, and 20. 36 is too big, 22 is too big, 53 doesn't work, 50 doesn't work, 49 is too big, 06 works, that is between 0, 1, and 20. 11 works, it's also in my good range there, and 81 is too big. So I am left with here 14, 03, 10, 06, and 11. So it turns out that using that row I didn't get any duplicates. These are all different, and I actually got exactly the number of labels I wanted. I've got 5 labels here, so I don't need to If I had more after 11, I would just ignore those, but I've got exactly the right number, so that works. So that leaves me with 14, 0, 3, 10, 0, 6, and 11. And if I go back to my list of songs here, I can tell what my playlist will be. So 14 is Up in a Puff of Smoke, 03 is Ring My Bell, 10 is Doctor's Orders, 6 is I'm on Fire, and 11 is Flashdance What a Feeling. So that's going to be my playlist for my morning run. So that finishes up this section. You should know what a simple random sample is, and that's just a sample from a population where any group is equally likely to be chosen. You should know what a table of random digits is, and you should be able to use a table of random digits to produce a simple random sample, just like I did in that last example.